In the last two lessons, we looked at the process of heat transfer termed conduction and then convection. Now, in this lesson, we're going to look at heat transfer via radiation. Now, whereas conduction and convection require some type of medium in order for the heat to be transferred from one place to another, when radiation occurs, no type of medium is required. That's to say, radiation is emitted through a vacuum. Now, we're well aware of that because the heat that comes to us from the sun comes through 93 million miles of space in order to get here. It doesn't require a medium in order to reach us here on Earth. But radiation isn't just emitted by hot objects. In fact, radiation is both emitted and absorbed by all objects that have a temperature. So, if we take this sample solid here, we can see that it's made of atoms closely packed together, and assuming that this solid has a temperature above absolute zero, so its temperature, that's big T, is greater than 0 degrees Kelvin, that means that the particles in the solid are vibrating. They will be vibrating, they will be colliding with each other, and as a result of that, they will become what we call excited. Okay, so the particles will be vibrating around in all directions randomly. Because the particles in the solid are vibrating, they'll become excited, and because that happens, they will emit radiation. Now, again, as I said, at the same time as they're emitting radiation, they'll also be absorbing radiation. So bodies are constantly doing this. And we can say all bodies. So if the body is hotter than its surroundings, then it will emit more radiation. And put that means more radiation than it absorbs. And conversely, if the body is cooler than its surroundings, it will absorb more radiation than it emits. So the amount of radiation that, for example, this body emits will depend upon its temperature. You can see that the hotter the temperature, the higher the temperature above absolute zero, then the more the particles vibrate, collide with each other, the more they become excited, and the more radiation they will emit. So let's just take three familiar examples. We have a person here at 35 roughly degrees Celsius. We have a hot teapot at around 60 degrees Celsius. And we have a kitchen stove, wood stove for example, at around about 300 degrees Celsius. Well, all three of these objects are hotter than their surroundings, we can assume, and they will be emitting more radiation than they are absorbing, but the relative amount of radiation that they emit depends upon their temperature. So this guy will be emitting some radiation. The teapot will be emitting more radiation because it's hotter, but the stove will be emitting a whole lot more radiation because it's at a higher temperature. Now, the name given to this type of radiation is infrared or thermal radiation. So you can't see this type of radiation, your eyes aren't sensitive to it, but just because you can't see it doesn't mean to say it's not being emitted. This radiation is constantly being emitted by all objects which have a temperature, and so there are devices, for example, thermal imaging cameras, which can detect the radiation emitted by these objects, okay, which help us to see things in the dark. Okay, and these are sensitive to this type of radiation. On saying that, however, the radiation emitted by objects can become visible. It's just that the temperature has to become a lot hotter, for example, than 300 degrees Celsius. Okay, so for example, a light bulb filament, when electric current flows through this tungsten filament, and I'm talking about the old-fashioned incandescent light bulbs, well, the temperature of these light bulbs can reach well over 3000 degrees Celsius. And so when you start getting to this type of temperature, going back to our diagram, the atoms in the solid are vibrating around so much, and they're becoming so excited, in fact, that they start emitting visible light. Again, so the object that we started off with in this lesson, that's to say the sun, has a surface temperature of approximately 6000 degrees Celsius. So as a result of that, the sun emits enormous amounts of visible radiation, going even further into UV light. There's a bit more to the story, and things can get a little bit more complicated with regard to the colour of radiation and the spectrum of radiation that's emitted from bodies with a temperature like this. And we will be treating that in the next lesson when we look at black body radiation.